Bismillahirrahmanirrahim. Dear viewers, today we will design steel portal frame in Autodesk Robot Structural Analysis 2020. So this is our plan and this is the section. This is internal portal frame. This is end bay at grid 1 and grid 7, and from 2 to 6 grid having internal portal frame with tapered section. We will go for frame 3D design. Here from tools we will choose our job preference. First we will check our regional setting. If we want to go for AIC steel design code, then we will choose United States. If we want to go for Eurocode, then we have to select this one. I will go for United States, this one. Language English, other things are okay except. Then go for job preference. From here, this is the database for AIC steel code. American Institute of Steel Construction, AISC. Unit, I will choose metric. Materials, American steel, I will choose here steel A 53 grade, this one. Click on OK. Now we will go for another thing we have to check here in the structural analysis. We will mark this one DSC algorithm bar release, and this one are link elements, rigid link, for using any rigid link in the model. Click on OK. Now we will go for creating axis or grids as per our structural plan. So go to geometry. From here also you can go, and here also you can go. Position 0 0 along x-axis. We will see along x-axis we will have here 1 2 3 4 5 6 7 grid. First grid distance 7.05, 7.05, and then 7 meter, 5 meter, 7 meter, 5 meter, 5 meter, 7, and last one is 7.05 meter. We will use ABC. Now go for Y direction. In Y direction 7.05, first one, 7.05 meter, add, then 7.2 meter, this one 7.2, 7.2, 7.2. So here 1 2 3 4 number of repeat. 7.2, repeat number 4, add, and last one is 7.05. this one number 1, repeat 1, click on add. So here total number is also 7. And Z direction we will check the height, eve height 8.75 meter, and ridge height 10.1 meter. So here 8.75 add, and from here to here 10.1. this is not scaled, so 10.1 minus 8.75. 10.1 minus 8.75, so 1.35. 1.35. click on add, so it will come 10.1 total height at the ridge level. Now click on apply, close. We can go for 3D view. This is our axis. Now we can go for defining our sections. Go to here also, geometry, from bar. From here we can create geometry, or from here also sections. We will go for user defined section. So tapered I. Here first I will choose this one, column 400 to 1000 millimeter. 400 millimeter bottom wave distance or wave length, and at top it is 1000 millimeter, and wave thickness is 8 milli, length 300 milli, width and thickness 12 milli. So go for SC 400 to 1000 cross 300 12 8. So here we can provide 4 to 10 for our realization, that 400 to 1000 milli, to make the name smaller, and others are in millimeter. This one 4 to 10, this is wave size. Now here starting this one be 300, and here wave height starting here 400, here in 1000, thickness of wave 8 milli, and thickness of flange 12 milli. Now click on add. Now for other section 950 to 400, 8 and 10, here 300 flange width. So I'll go for 950, sorry, here 950 to 400, here wave thickness 8 and flange thickness 10 milli. Now here 300, here it will come 950, and end will be 400. This will be changed 10 milli, add. Here strut box 175 3 milli, so go for this one. Strut 100 75 3 rectangular strut, so B75. Here we are doing one mistake. Here see, it is in centimeter, so we have to go for 7.5. height is 10 and thickness is 0.003 centi. Then click on add. We can edit our sections. Still column, here centimeters, so it will be 30, 40, 100, 0.8, 0.8, 1.2, 1.2. So add modify. Now this one 30, 95, 40, 0.8, here 1 centi. So add, yes, modify, still column, close. Now we can bring our edit tools here as a shortcut. Go to tools, customize, show toolbar, edit, close. Here from here we can use these toolbars for editing our member, for copy, move, mirror and other options. Now we will go to elevation view, X, Z, structure axis 2. We will create our internal portal frame, simple bar, SC, structural steel column, this one, then from here to here, from here to here. Now for this rafter, 950 to 40, from here to here, from here to here. Now we can check the distance for this split off. From here to here, this is 7.8 meter. So select these two, then here division in distance 7.8, generate nodes without bar as division. We want to divide the bar, so we unmark this one, execute like this. Now here we can see this is divided, but here not the 40 centi width of web, it is in the middle, so here larger than 40. So first we can change the section for this one, 95 to 40, apply. So now here width is 40 and this one 40. Now this one we will change the section 40 to 750, 40 to 75 centi. Now this is the direction, click on this. Here this is the direction from this side to this side, like this. Now this is our internal portal frame with tapered section. Now this one we can copy. We can go for 3D view, 4 axis or grids, select this, then go to translation, this is select copy, the number of copy 4, distance will be from here to here. Now we will go for end base at axis 1. For in base, this is our section. Grid 1, B, C, E and F. There is rafter, column rafter for in bay. So go to XZ axis, grid 1. We will model our end column in the end of same like internal portal frame, so that we can get same slope for the rafter. This is in rafter ER from here to here and from here to here. Now I will move these in columns to grid axis B, grid or axis B, and here F. I can turn off this grid view. Go to grid step definition, click on grid off, apply. Now select this, go to move from here to here. Now for this one also select move from here to here, close. Now we can extend our member. Go to extend, select this boundary, then object, this one. Now this one delete, select this one, then this one, like this. Now we can trim our rafter up to these columns. Go to trim, cutting object, this one, trimmed object, this one. Sorry, we have to click on this side. First this one, then this one, 36. Okay, now this side select. For here select the cutting object, this one, and select 35 here, and this will be 37. We have to select the side from which side we want to trim. This side we want to trim, so select this one, click OK. Now this is done. From here to here we need to draw another column, this one EC, from here to here and here to here. Again we can extend this one, this object is this, and again for this one, this. So this is done. Now we can rotate these two columns, because we want to keep the major x-axis, major z-axis in outward side. See here, this major z-axis will be outward side. We can see the axis in view, display, local axis, major z-axis, we want to see view, node bar model here, local system, local apply. Okay, so here see Z is the blue color, so local Z axis of member should be in outward direction. Here we can see in the model for this rafter, here this side column should be rotated, this, because we want to keep this local Z axis in outward direction. Here we can change the gamma. Here is the gamma 180. Okay, now see, this is in outward direction. This is also outward direction. This also need to change 180. Okay, and this need to rotate. You can check 90. So this is rotated. So here this local Z axis in outward direction. Now this end bay we can mirror, go to mirror, vertical mirror, XZ select, here middle. Now it is done. Now here we can see this is in reverse direction, Z axis. So we have finished our main frame modeling. We can go for our support. From here we will create our portal pinned support. All translational action will be fixed. This will be free. Only rotation along Z direction will be fixed. So click on add. Here we can go to the front view and select the base point of these frames, then go to here. You can see this is the selection of nodes. Now click on apply. So this is our support for our portal frame. Now we can go for modeling of strut this one. From here drag here. Now close this one, and in the middle also go to here, drag, so close. Now we can go for bracing modeling. We can remove this axis, local axis, from our view. model local system, this one, apply, done. Now go to section, we'll define rod bracing, this one, solid bracing 25 millitire bar 2.5 cm, add, okay. Now we will model our bracing. We will see this bay and this bay is having bracing. So from here drag this one, this is not exactly middle, so we will create a node here. This is 7.8 meter. You can see here the length by keeping the cursor on the member. This is 7.8 and this is 11.3 meter. So 7.8 and 11.3, 11.3 plus 7.8, it will be 19.1 divided by 2, 9.55 meter will be the midpoint from the starting point here. So here already 7.8, so minus 7.8, so 1.75 meter distance we will create node here. We will go for division, distance 1.75, generate nodes without bar or edge division. This is okay, execute. Now done. Now we will create bracing. This is 25, okay. From here, this is the node here. Now from this side, this and drag here and this, close. Now this bracing we can mirror here, vertical mirror, this time X, Y, Z, this is okay. Now click here like this. This is done. Now we can select all the bracings, select by cross section, then go to copy from here to here. So this is finished. We can go for bracing modeling. Job preference, database, steel here. We need to add Australian section, AUS. Click on OK. This one, click up, then click OK. Go to section, new section, aluminium, go for Australia, here Z. From here we can select 200 milli Z Purlin thickness 1.9 mm. Add, close. You can see this is Z shaped. Done. Now we will model this jet purlin. So we can start copying this one along this direction. First we will create a node here at a distance. This one, any one member. If I take one node, we can copy this one, select this one. Our bracing distance is 1.4 meter. So 1.4 meter, execute. So here is the node. So I can copy this one, from here to here. Number I can choose it here. We can see 11.3 plus 7.8, this one divided by 1. So here 13 number will come, so we will put 13. So go to copy number 13 from this point to this point. We can change our display setting to differentiate the section by color. View, mark with color, section by color, like this. Now this one, select cross section, then go to mirror, this YZ, okay, and middle is like this. Copy in other base, select cross section, then translation. Here 1, 2, 3, make it 3 or make it 4. We will trim this from here to here, and click on here. From here to here, you can go for this view. This is okay. Here you see this is extra 0.5 meter. We can see our axis 7.05. This is okay. Here this side it is coming, so we will make this side copy, select by cross section, then view, or here we can go for editing new window. Go to copy from here to here, exit. Now here we can trim the extra line, trim here. This is the object, trimming object, and this is like this. And for this side, this one, and here this. In this way we will trim the extra portions. We have finished our trimming. Okay, now we can save the model. Save his portal frame 3D. Save. Now this is our modeling of portal frame. This end section, this may be here in drawing, this is as a beam, so we can make it beam. Select this and this one. Go to section, go to end drafter, apply. Now we will release secondary members. For example, this one, select cross section, here go to geometry, releases, this will be pinned, apply, close, and for this strut, select by cross section, geometry, additional attribute, release, and then apply, pinned, close. Now I will go for bracing. This one, geometry, attribute, advanced bar property, we will assign truss section, because bracing can act as tension only member for the axial load. We will go for tension bar. Now click on apply.
Press the bell icon on the YouTube app and never miss another update.